Dear students, now we treat chapter 5 in the course of image processing, this chapter entitled Image Operations and Histogram. In part 1 of this video, concerning image operations and thresholding. So as we discussed before, the image is formed of points of pixels called pixels, which is the smallest elements of the digital image. This pixel has two parameters. The first parameters are the XY, which is the position of the pixel on the image. And as we said before, the image that is constituted by pixels and characterized by its number of rows and columns, number of pixels over the rows and number of pixels over the columns, which represent the size of the image and the characteristics of the image, which is a colored image and other parameters. This image is represented by a matrix of data where each value of the matrix represent the intensity of the image, which is a second constituted of the pixels. So IXY contains the intensity of the color information, where XY define the position of the pixels and the XY represent the value or the intensity that defines the color. And the value of pixels, or the value that a pixel can take, is determined by the quantification level. And we talk about the quantification level in a previous chapter. So if we talk, for example, about binary image, in the binary image, each pixel is represented by only one bit. And this bit can take two values, 0 or 1, 0 for the black colors and 1 for the white color. So in this case, the image is formed only by two colors, white and black. And as we said, each pixel is represented by just one bit. So this is what we call the quantification level. Now, if we talk about 8-bit image or 8 gray level image, in this technique, each pixel is represented by 8-bit. And we talk about unsigned numbers, which means that in signed number, for example, we have 1 bit for the signed, plus or minus, and 7 bits for the data or the number. Here, in the unsigned number, the 8-bit represent the values, and the pixel values range from 0, when we have 8 zeros, which is the minimum number and represent the black color, and the maximum number is 255, which represent 8 ones. And all the values, the others value range between 0 and 255. If we have a number that approaches 0, which means that it's a dark gray color, and if we have a number that is nearest the 255, it means we talk about lighted gray color. Now we start to study some techniques of processing of the image, and we treat now the operations up in pixels, which means that we make a transformation on individual points or pixels, where this transformation is applied pixels by pixels. So in general, we may have transformation by region, where we apply the transformation on a region or a group of pixels. Here in this part, we apply the transformation on pixels, pixel by pixels. And this is the most basic type of image processing. In this case, we take the intensity of the input pixel, which is the original image, and we apply the transformation, and we obtain the resultant image, where the intensity of the output image or the resultant image is just the value of the transformation of the intensity of the original pixel. So I output could be the result of transformation, or could be a result of the operation between two images. For example, if we have two images B and C, I can obtain a new image IA based on the value of pixels of the B and C. we can, the output could be a result of operation between an image and a constant C. So we can add a constant C to each pixels of the image. So this is what we call the transformation. So the transformation is divided into two values. Either we add value to each pixel or differentiate value to each pixels, or we make some arithmetic operation as multiplication and division on the original pixels, or we may apply the arithmetic operations between, we may apply the arithmetic operation on two images. So the kinds of operation in general are two: arithmetic and logical operations. When we talk about arithmetic operation, it means that addition, subtraction, multiplication, and division. We can add constants, we can subtract a constant, we can multiply the intensity of pixel by a constant, or divide the pixel intensity by a pixel. Or we can add two images, subtract two images, and make any combination, linear combination, subtraction. So in this case, we can find a new image. So if we want to add or subtract two images, it means that we have to add or subtract their appropriate matrices, because each image is represented by a matrix. So for that, the matrices should have same size, which means that two images should have same size. And we talk about same size, it means have same number of pixels in rows and same number of pixels in columns. The second problem that we can reach in this operations is the problem of overflow and underflow, which means that the ranging values of the gray scale image is between 0 and 255, as we said here, because we use 8-bit pixels. So the minimum value is 0 and the maximum value 255. Now, if we add two images, suppose the first is 150 and the second 150 as intensity, so the summation is 300, which means that we have a problem of overflow, where the sum of the two, the summation, will give a number greater than 255. Also, when we have a subtraction, the subtraction may result on a numbers that will be lower than 0, which is in negative numbers. So this is what we call the problem of overflow and underflow, where the addition can cause an overflow, which means the addition of the two intensity may exceed 255. Also, subtraction can cause an overflow or underflow, where subtraction may lead to a numbers less than 0. So to solve this problem, we'll apply the MATLAB function to adjust these operations, which is image add and image subtract. In image add, if the summation is greater than 255, the number will be set to 255. And in image subtract, if the subtraction of two numbers is less than 0, so the value will be set to be 0 as a black color. So let's start by some application. First, add or subtract a constant. So why we add or subtract a constant, and what is its effect on the image? So if we had a numbers and we add a constant to each pixel, which means that the value approaches 255. So the colors of the image or the intensity of the image will be more lighted, which means that we decrease the darkness of the image. While if we subtract a constant, the values become more lower, the values become nearest 0, and which means that the image becomes more darkness. So adding a constant or subtracting a constant, as it's similar, that we adjust the contrast of the image. We increase the darkness of the image or we increase the darkness of the image. This is what we call contrast adjustment. So IA equal IB plus C or IA equal IB minus C, which means that we have the original image IB, the original image B, with the intensity of each pixel I, and we add a constant C to every pixel. And the resultant image is the image A with intensity I, as similarly to the IA equal IB minus IC. Okay. Let's take an example. This is image read. We read the image cameraman.tiff. We add to the image A the number 50, then we subtract 70. And we make subplot. We talk about subplot and axis title, all this part, we talk about it in the previous chapter. Now, when we add 50, it means that we increase the brightness. This is the original image. When we add 50, all the values, the original values of pixels are increased by a rate of 50, and the image, the brightness of the image becomes more lightly. Now, if we subtract from the original image 70, it means the values become lower and the brightness becomes more dark. So this is the effect of adding a constant or subtracting a constant from the image. It's just we increase or decrease the brightness, and which means that we decrease the darkness or increase the darkness. Now we treat the addition or subtraction of two images, which causes the blending effect. So when we add two images or subtract two images, we merge these two images, and the two images are mixed together. And this effect is called blending effect, as we blend or we merge the two images together. As we said before, to add two images or to subtract two images, it means that we add the element of the matrices or associated to these two images. And to add two matrices, we should have the same size. So you cannot add two images if they don't have same size. So first, image should have same size to be added. Second, the image should have same data type. I cannot add a binary image to image are represented by 8-bit as gray level, because the first image, each pixel represented by 1 bit, and second image is represented by 8-bit. So to add two images, the number of bits that represent each pixel in the two images should be the same. So the same, in order to add two images and to not have the problem of overflow and underflow that we talked about it in the previous slide. So to prevent this inconvenient outcome, so we use image add, image subtract, and image abs difference, which means that image absolute difference. So we differentiate between the two images, and we take the absolute value of the resultant image. So image add, image subtract, image abs difference can be used to add, subtract two images. So why we use image subtraction? Image addition can giving a blending effect, and we can see the two images together in the same image, in the resultant image. What is the purpose of differentiating two images? In fact, the image subtraction shows the difference between images. So if we have a pixel that does not change, if we have two pixels that do not change its values or its intensity, the difference is 0. Now, if we have two pixels where their values are changed, the difference is different from 0, which means the difference show the difference between images. What is changing between the first image and the second image. And this application, the difference between images, is widely applied or used to detect movement. So if we have an image and I want to see if we have any movement on the image, so I differentiate two successive images, taking, for example, from video surveillance camera, and the difference between these two images. If the difference is 0 for all pixels, it means we don't have any movement on the scene. But if we have any pixels where the value are different from 0, it means that we have a changing on the scene, which means that we have any movement or changing from one pixel to another. And this is widely applied to detect movement or changing in scene between frames, and represent the basic principle for motion detection in video processing. For example, if I am using a video surveillance camera to detect if any intruder want to steal my home, for example, I can put a surveillance camera, and every second, for example, I can take one photo, and using an algorithm, I can differentiate between the successive images. If the difference between image I and image I minus 1, for example, is 0, it means no one is presenting on my home, for example, or nearest my home, and or on my garden, for example. For example, when they make a movie, when they make movie, they take a photo or a scene, for example, for a person. Then they take another photo for a mountain, and after that they merge the two photos, and we see that this person is have a background mountain. So in this case, we can make this mixing of photos. The image differentiation, this is the original image, for example. This is used in industry. This is a board, for example. This board, this is the original board, and in the manufacturing process, we should process the same board, and in order to ensure that the fabricated board or the produced board have the same feature as has the same feature as the original image or the original board, we subtract these two images. If the subtracted images is 0, which means all the color is black, which means that the produced board is similar to the original, and it's this board will be approved. If we have a white colors, which means that we have difference between the original image and the fabricated or the produced image, so this produced board has artifact or defects and cannot be sent or approved. So in this case, we can know that if the items produced are within the recommendation or whether the recommended specification or not. So as we said, addition is to merge two photos, subtraction, differentiate two photos, and see the difference between them. Okay. Now, let's take an example. This is a real example that we can take from MATLAB. We take the image coins, .g. This is a real image. We have a size 246 by 300. This is the image read 8. We have the size 242, 308. So these two images cannot be added. Why? Because they have different size. This is 246 as number of rows in pixels. This is 242. This is 300. This is 308. So in order to add these two images, I make a same image, same size. So I add the image A from 1 to 140. So I delete 6 rows from the image, the first image, and 2 rows from the second image. This is number of rows, 300 is 308. So I cut 8 columns from the image B in order to have same size. 240 as number of rows and 300 as a number of columns. So I cut here 6 rows. Here I cut 2 rows and 8 columns. And this process, in order to have same number of rows and number of columns, to means same size, in order to make the addition or subtraction function, to apply this function. If I apply A and B directly, the function will return an error because A and B do not have the same size. And after we make the addition, this is the resulted image. We see the 2 images, and we see that we have a color, red color, white color, because when we add the 2 values, the resulted after the application or after the addition, the values are high, approaches 255, which means the majority of color will be lighted or white. So if I want to reduce the brightness of this image, I may differentiate a constant. You can apply this to your MATLAB. You can image add A and B, then we can apply subtract the resultant image C, for example, by 70 or 80, and you can see that the brightness of this image will be lower and will be more darkness and not whited image as we have seen here. Image addition and subtraction. Another application, we take the first image and the second image. These images are also in the MATLAB toolbox. These 2 images are taken for a particles moving as a cell, successive images. If we differentiate between these 2 images, and you can see that these particles are moving. Okay, these small particles are moving, and we can see here and here, this motion, the motion of these particles. So where we have black color, it means we don't have any motion. Here we have a light motion of these particles, and we can detect by the image subtraction we can detect the difference in the scene between the different images. Now we go to the image multiplication and division. What is the effect of multiplication and division on the contrast enhancement? In fact, if we add, if you multiply the pixels by a value greater than 1, it means that we increase the values of the pixels. So if I multiply by 1.5, 1.2, 2, any number greater than 1, it means that the values will be increased. Increasing the value, it means that we increase the contrast and the brightness of the image increase, and the colors become more lighted and approaches white color. If I divide by a number less than 1, if I divide a number less than 1, it means that the value of the intensity will be lowered, and the contrast, which is, we lower the contrast of the image, and the numbers will be lower, approaches 0, and the image will be more darkness. Will be more dark. So in general, image multiplication and image addition are used as an extension to add and sub. So we may add and divide, then we make an addition. For example, if I divide by 4, I reduce the contrast by 25%. If I multiply by 1.5, I may increase the contrast by 50%. So we can apply any other numbers. So just this is an example. Also, we have a problem of overflow and underflow, as you know. If I multiply, for example, if the value of pixel, for example, is 200, and I multiply by 1.5, So the resultant number is 300, which is greater than 255. So I will obtain a problem of overflow. The same if I have a value of pixels 1, for example, and I divide by 4, I will obtain 0.25, and which is value lower than 0.25. So in this case, we have to adjust the numbers when we multiply, when we divide by numbers giving floating numbers or values greater or greater than 255, because I may divide by numbers, by smallest numbers. I may divide by 0.1. In this case, it's similar to multiplying by 10. So for that, to solve the problem of the overflow and underflow and prevent of obtaining numbers that is lower than 0 or greater than 255, or obtain a number that contains floating points. In this case, we use image multiply and image divide. Image multiply and image divide can solve these problems, and these functions are presented in the MATLAB toolbox. For RGB images, as you know, we have three, for each image, we have three matrices. The first matrix is for red color, the second matrix for green color, and the third matrix for blue color. So each image is represented by three successive images. So for that, when we want to apply arithmetic operations, addition, subtraction, division, multiplication, etc., we have to apply these operations on the three channels. Okay, let's take an example. This is image read for cameraman.tif. First, we multiply by 4. We divide by 4. When we're dividing by 4, the numbers are reduced by 25%. These values will be lowered, and the numbers are approaches 0, which means that the image will be more darkness and the brightness is decreased. Now, if we multiply by 1.5, as you see in here, by multiplying by 1.5, the brightness will be increased. Why? Because the numbers of the intensity of the original image are multiplied by 1.5, are increased, approach 255, and the majority of pixels has increased values, approach 255. So we will see an enhancement of the contrast of the image. Now let's take the example of multiplication and division concerning two successive images. This is what we call image subtraction. We see this example before. We take these two images, which are small videos, and these two images, 83.1 and 401 and 02, are two successive images. And we take the subtraction between these two images, and we talk about that these values represent where we have motion between the acquired between the time when we take the photo the photo of those two images. So between the first image and the second image, when we take the first photo and we take the second photo, the movement between these two images can be detected on the values where we have white or gray colors. The black pixels mean that we don't have any motion in this part. So now if I want to enhance the difference, I will multiply the difference by 4, because if I have a small change in the or small movement, the difference will be lower. Will be, for example, 10, 15, 25, etc. And these small values approaches 0 and will be represented by dark gray colors, which is similar to the black color. So in order to increase the enhancement and to see very well the difference between the two images, I may multiply the difference by 4, and this multiplication will increase or will enhance the difference between two images. So for that, when I multiply here this image by 4, I can see very well the difference pixel by pixels between the difference between these two images. And of course, this image, the characteristic or performance of this image is more powerful than this image. So for that, when we want to subtract two images, after the subtraction, we multiply by a constant number, 4, 5, 3, etc., in order to enhance the difference between two images and to see very well the difference or the motion of particles of any element that have changing between the two frames or images. Another example, we have these two images. We make an addition. Now, when we make an addition, when we add these two images, we multiply the first image by 0.8 and the second by 0.3. Why we take 0.3 for the second? Because we have a white, near white background. So if we add any values to this near white background, the values will be white, as we have seen here. Here we add these two images. So we obtain a white background. Why? Because we have here near white background. So any values that can be added, this value will be will reach 255, and we will obtain a white color background. So in order to prevent this saturation of numbers, where the numbers reach 255 or more, so for that, we multiply the value of these pixels by a small value in order to decrease the effect of the white, near white background. So for that, we multiply this by 0.3. So this near background will be lowered by 66%, about 66%. Here we multiply this by 0.8 only, just to prevent the brightness of the coins. And when we add these two values now, we make the addition, we can see that the combination of these two images, or the merging of these two images, is more significant than the previous addition, when we didn't use 0.8 and 0.3. So you can play with this. You can make an addition of two different images, any two images. You can take any two images having same size, same representation of pixels, same type, data type, and you can change 0.8 and 0.3, and every time you can see the effect of these parameters. You can use 0.5, 0.6, 1.2, 0.1, etc. And every time you can obtain a resultant image, and you can see the difference or the effect of these two numbers when you multiply each matrix or each image by a constant. What is this effect on the combination or of the addition of these two images? Now we go to the logical operation. When we think about logical operation, it means you apply OR functions, OR, and NAT, XOR, etc. Also, these logical operations are performed on individual bit. NAT, it means the inversion. So the NAT of 0 is 1. It means we invert the image representation from white to black. In binary image, the black becomes white and white becomes black because the binary image is formed by 0 and 1. So the NAT of 0 is 1 and the NAT of 1 is 0. So when we apply the NAT function, when we apply the NAT, the logical NAT on the pixels, the white becomes black and the black becomes white because 0 becomes 1 and 1 becomes 0. Now, if we are talking about grayscale image, where the ranging value is between 0 and 255, so the NAT, it means that we take the maximum minus the intensity of input. So the resulting intensity is 255 minus the intensity of the input image. So if the input is 0, the maximum 255 minus 0, which means it becomes 255 white. And if it is white, 255, then the difference is 0. So white becomes black and the black becomes white. And if we have values nearest 0, it becomes nearest 255. And if we have values nearest to 255, it becomes nearest 0, which means that if we have colors nearest the white color, gray color nearest the white, it becomes dark nearest the black. And if we have dark color, dark gray color nearest the black, after applying the NAT, it will obtain a brighted gray color. So to apply the inversion or the NAT, logical NAT, we use a MATLAB function image complement. So let's take this application. Logical, we has a cameraman. We apply image complement. So the black becomes white, the white becomes black, the lighted color becomes dark color, and the dark color becomes lighted color. This is what we call the image complement. Sometimes we apply image complement in order to enhance some details on the image, in order to see some details on the image that cannot be seen without application the image complement. OR or XOR, it's useful for processing binary values image. Also, it can be used OR or XOR to detect the object moving between frames. So if we have a binary image, in general, binary image have two